Number 14, the series n equals 1 to infinity of n factorial over 100 to the n. So we have that factorial in here, so now's a good time to use the ratio test. So I have L is equal to the limit as n goes to infinity of the absolute value. And now I'm going to do my n plus 1 term. So I'll replace all of the n's with an n plus 1. So I have n plus 1 factorial over 100 to the n plus 1. And then I need to divide by the a sub n term. Okay, so that means I'm going to multiply by the reciprocal. So I'll have an n factorial in the denominator and a 100 to the n in the numerator. So this is equal to the limit as n goes to infinity of n plus 1 factorial over n factorial times 100 to the n over 100 to the n plus 1. Okay, so let's go ahead and simplify that. So we get the limit as n goes to infinity, and I can take the absolute value bars off because everything here is positive. So n plus 1 factorial over n factorial is n plus 1. 100 to the n over 100 to the n plus 1 leaves me with just 100 in the denominator. And as n goes to infinity, this is going to go to infinity. Okay, so my limit goes to infinity or does not exist. So my conclusion is, since L goes to infinity, which is definitely bigger than 1, the series n equals 1 to infinity of n factorial over 100 to the n diverges by RAT, by the ratio test. So there is our conclusion, and there's our supporting work for that. All right, so let's take a look at number 15. I have the series n equals 1 to infinity of n factorial over n to the n. And I'm going to have you pause the video and try this one on your own, but I want you to note I'm giving you a hint here because you're going to need this limit. So the limit is n goes to infinity of n plus 1 over n, all of that raised to the n, is equal to the letter E. Okay, so go ahead and pause that video and give this one a try, and we'll come back and work on it together. All right, so let's take a look at this one. Let's see if we get to the same conclusion. So I'm going to start by writing out my limit. So I have L is the limit as n goes to infinity. I'll do my absolute value bars here. So my n plus 1 term is going to be n plus 1 factorial over n plus 1 raised to the n plus 1. That'll be divided by an n factorial multiplied by an n to the n. Okay, so hopefully you got your terms lined up like that. As you get more experience with the ratio test, you'll actually start writing your terms out in these groupings so that you can skip a step and just jump into the simplification. So let's see what we have here. I have the limit as n goes to infinity. All of these terms are positive, so I don't need to worry about these absolute values. N plus 1 factorial over n factorial is going to give me an n plus 1 over 1. And here it looks like I have an n to the n over an n plus 1 to the n times 1 over n plus 1. So what I did was I took this n plus 1 and I split the n and the plus 1 part here. So here's the n plus 1 to the n, here's the n plus 1 to the first. So these two cancel out. I'm left with n to the n over n plus 1 to the n, which looks an awful lot like this, but it's just flipped over. So this limit here is going to go to, instead of e, is going to go to 1 over e. Okay, so I'm ready to write my conclusion, and my conclusion is, since L is equal to 1 over e, which is less than 1, my series n equals 1 to infinity of n factorial over n to the n converges absolutely by the ratio test, by RAT. Right? So there is our conclusion statement.